In this tutorial, I am going to explain how to do the static analysis of plate using SolidWorks. In SolidWorks, select a new file, and in the new file, go to the part module, click on part and OK. Then this is the SolidWorks environment. Before starting the drawing, check the units. For that, go to options somewhere here, then go to document properties, then click on units, and here check the unit system. This must be in mmgs, millimeter, gram and second. Okay, if this is in any other system, change it to mmgs, click on OK. Next, go to the front work plane, right click on this, select a new sketch, go to the center rectangle here at the center, then go to smart dimensions, take this length as 160, width of the rectangle is 100, then go to circle command, draw one circle at the center, another circle somewhere here, go to dimensions, this circle diameter is 20, this circle diameter is also 20. Okay, then go to chamfer command, take the chamfer distance as 20, select this side and this side, then you will get chamfer. Okay, then go to trim command, keep this in power trim, then delete the unwanted area like this, click on OK. Now exit from the sketcher here. Now your sketch is ready. You have to convert this into solid. For that, go to features tab, then go to the extruded feature, then extrude this to 10 mm. Okay, then your model is ready. Now you have to go for the analysis. For going analysis, go to tools, add-ins, the SolidWorks simulation tab you have to select like this. Okay, then you will get this simulation tab here. Now go to the simulation tab, then go to new study, then here give the name as a plate, click on OK. Then here you have part 3 is there, but material is not yet assigned. Then for assigning the material, go to the apply material, then by default I am taking the alloy steel. If you want to go for your custom material, here you can go for the custom material, and you can edit all these values. Here you can keep them in megapascals also, and you can edit all these values. So that is the custom material. You can rename it also with your material name. For the time being, I am using alloy steel. Click on apply. These are the various properties of alloy steel material. Select this, click on apply and close. Now observe here, alloy steel material is assigned to part 3. Okay, so this is the dynamic help. I don't want this, that's why I am just turning off it. Next, now go to the fixtures. So here I want to fix this particular surface like this. These are the boundary conditions. This is the area where we can apply the boundary condition. So one boundary condition is constraining this particular face, that means fixing this particular face. Okay, select this face, then click on OK. Observe here how I am doing this. Again I will explain. Go to fixtures advisor and go to fixed geometry, then select this face, then click on OK. Now that particular face is fixed. That is one boundary condition. Next, go to the external loads, then select force. I want to apply force on this particular edge. Select this edge. Now by default option is normal, that means this force is acting normal to that edge, but I don't want to apply the force in normal direction. I want to select the direction. Go to select direction option here. Then once you go for select direction option, here you will get one more block. So in this block you have to select one edge in the direction parallel to the application of force. That means my force direction is parallel to this particular edge. I am selecting this. Now it is acting in the upward direction. I want to change the direction. So go to reverse direction. Okay. Now you can reverse the direction like this. Then what is the magnitude? Magnitude is some 1000 Newton. 1000 Newton force I want to apply. Okay. Click on OK. So my complete model is ready. Boundary conditions applied and force is also applied. Now you have to go for meshing. That means we are splitting this complicated problem into some small simple problems. That is called meshing. After meshing you can run the problem for getting the solution. So create mesh. So here keep this in towards fine somewhere here. Don't keep this in chorus, somewhere needed to fine. You first keep this and run the problem. Now meshing is ready. Now solve the problem. Run the study. Okay, your problem is ready. This is the yield strength. This is the maximum induced working stress. Yield stress by this working stress will give the factor of safety. That factor of safety we can get directly here. Go to new plot, then go to factor of safety, and I want to get the factor of safety with respect to these stresses, that means von Mises stresses. Observe here in von Mises stresses V is small letter and M is capital letter. That is one important observation here. Then click on OK. Now factor of safety distribution is 7.2. That means factor of safety we are getting a 7.2. Now again run this. By recreating the mesh, now factor of safety is 7.2. I am keeping this towards fine somewhere here. Then click on OK. Again run this. Now go to result advisor. Again check the factor of safety. Okay. Now factor of safety is 6.1. Now again recheck it. We have to solve the problem in such a way that till the factor of safety remains same from two successive studies. So run the study in such a way that this particular factor of safety obtained remains constant. That is called as convergence of the problem. So again I will check for the convergence. I will go for creating mesh. I will move it further like this. Then I will run the problem. Again I check the factor of safety with respect to this von Mises stress. Okay. Now it is 6.9. That means 6.1, 6.9. Only decimal place is varying. So that's why the problem is reached to convergence. In this way you can find the factor of safety by doing the static analysis of the plate.